Good evening, everyone. Welcome to this last talk in the series of SURATi TechTalks 2022. This particular talk is on microservices, what and why, and we will be seeing about microservices architecture, and also related to that, we will be see how it is highly maintainable and testable, how loosely coupled it is independently deployable, and many more things that Ankesh would be taking over here to talking to us over here. And a few lines about Ankesh. So Ankesh is CEO of Xtreme Softtech, and he is also co-founder of TechTalks, one of the startup that is incubated by SURATi iLab. So Ankesh Maradia is a hardcore technologist, and he has specializations in Microsoft tech stack. He is having more than 15 years of experience in project management and project development using various .NET technologies. He is a co-founder of TechTalks, as I have told you, and he has more than hundreds of happy clients with his particular TechTalks stuff. So he, as I have already told you, is incubating over here, and he sits with us over here in SURATi iLab and uses the co-working facilities of SURATi iLab. So without wasting much of the time, I would request Ankesh to take command of this particular session and start his presentation. Ankesh bhai, please continue with your presentation.
Thank you so much for the introduction, Tejas bhai. So that was a very good introduction, and thanks for that. So this is the last session. I would say that it has been 2 long days for wonderful session, lot of information, and I'll try my best to contribute to that and end on a high note. So what I would be covering is just a scratch the surface of microservices. Microservices, we have heard a lot. What is microservices? Everywhere, everyone talks about microservices. So now where to use that and how that can be used, whether it can be used on all these scenarios or not, we'll look at that. And also we'll kind of touch base upon what are the different practices, best practices, design patterns, and tools which can be helpful in developing microservices. So I'll share my screen. Okay. If anyone can confirm if my screen is visible.
Yeah, yes, it's visible.
Okay, thank you. So this is the talk, my first talk in SURATi Tech Talk. That got kind of a brainchild this year by Tejas Patel, and this topic covers microservices. So I'll start with it. So agenda. So we will cover this points in this session. What is microservices? Principle of microservices. What are the benefits we get? What are the building blocks which we kind of need while building the microservices? As microservices are independently deployed and runs, how the data management works, what should be done or what can be done in terms of data management. What are the success facts and factors for the microservices, the various development and deployment tools, and let's say if we want to convert our monolithic application into microservices, how can we do it? Okay, so first introduction. So we'll cover the definition. Microservices is also known as microservices architecture. So microservices is an architectural style that helps us develop small services, deploy them separately in a container. We'll hear this lot of terms, containerization and all. So we'll understand them better as we move forward. So small microservices are kind of deployed in various containers. Those are highly maintainable. They are individual services, so they are easily testable. They are loosely coupled. You can deploy them independently. You can organize or develop microservices based upon the business requirement. and each microservices can be owned by a team, and a team can actually own more than one microservices. So microservices architecture, once this base architecture is set up, how things are kind of needs to be placed, the further development is very rapid, as you don't have to think about a very long term, very big picture. You just think about what is a particular functionality in this module or this particular service, and you just develop that. So you don't worry about a lot of other facts. Okay, what will happen after that? What will happen before that? So that entire architecture will take care of it, and we'll see how the communication happens and all. So what are the principles of microservices which you should keep in mind while developing it? They should not share code or data. So that means it doesn't mean that you cannot write reusable components and use them. It means that a particular piece of microservices, the project needs to be separate. So a particular team can work on it, deploy from that particular project. So you don't have to kind of create a big solution and then deploy the particular solution at one location. You deploy various small microservices. Also, each service takes care of its own data, because if let's say if we so the data strategies are kind of a complex over here, because each microservices owns their data, but that data also needs to be shared. So we'll see how that data sharing or transaction can be done. But the principle is data should not be shared, or kind of a same data source cannot be used by more than one microservices ideally. Avoid unnecessary coupling between services and software component. So if you don't need dependency on any other service, just kind of don't couple them. Have microservices individually. Independency and autonomy, no single point of failure. Because if a particular microservice goes down, there's a monitoring infrastructure which monitors and it brings up another instance of it. So that way, if something gets failed, you have a set of other microservices which can serve that request, right? So that's the beauty of it. Should be responsible for single system or function or process. As I said, each microservice should be only responsible for that particular set of function, not more, not less. Microservices should not communicate directly with other microservices. They ideally they should kind of interact with event bus. So we'll see what event bus and how those can be used. Okay, what benefits do we get? So if you write a code which can be deployed as a microservices, I can bet that that code would be very modular. Otherwise, you cannot really kind of deploy it as a microservices. So now, if the code is modular, it kind of reduces the complexity for the microservice. Also, let's say if you want to make some modification, you are touching that particular functionality. You are not kind of touching any other functionality. So in that regards, the impact of or the change impact for particular microservices limits to itself. So it doesn't kind of really impact rest of the system. So if some code change went wrong over here, other microservices won't fail. It only this will fail. So that kind of reduces the impact of it. Enables continuous delivery and deployment. So we are in a very fast-paced environment. So there you kind of churn out a lot of builds. Initially, the deployment would be in months or in quarters or in kind of a half year or year. Now you have kind of a 20, 50 deployment in a day. How do you achieve that? So if you don't kind of automate the continuous deployment and delivery, you cannot really do that, because lots of microservices or lots of deployment or fixes needs to be up to date, right? So you need a system where those deployment can be seamless and kind of continuously done. So it creates an architecture which is highly scalable. So imagine, so I'll take an example of a kind of a Flipkart or Amazon over here. So when they have a sale, right? So the number of users hitting the server, let's say number of users searching the product, it kind of a multiplies into kind of a, when there's a kind of a sale, when there's a discount, right? When there's a kind of a Flipkart 3 days event where everything is on huge discount. So user base is such. You need more power during that period. But at the same time, on a routine days, the power would be a lot less. Okay. So now for that particular 3 days or 4 days or 5 days, you need your double capacity of the server. Otherwise, you need only half. That's where microservices came into picture. That's the beauty of it. So microservices can run on its own, and let's say you can have, let's say, search microservice which searches the product. Generally you have 10 instances of that service running, but when there is a sale, you can kind of spin it off to probably 100, right? And after sale is done, you can kind of trimmed out to again 10. So if you follow this kind of architecture, the scalability or the on-demand thing can be very easily handled, and you can really scale very fast. Also, it saves you cost as well. If you don't have to always buy kind of 100 server, even if when you need only 10. So that way you can kind of save the cost as well. Also, these services are deployed separately. So in many projects, what happens is we start with some technology. Okay, we use that technology. That technology was boom and was providing more functionality during that period. But as the application grows, as the time grows, there are new technologies, and for particular set of problem, let's say I'm using .NET for most of the deployment. But let's say if I want to do a very kind of a chat kind of an application, which needs very small footprint in terms of communication and all, so I might go for Node, right? So if I use this architecture, I can use different technology for different services. Nobody stops me. The only thing the service needs to do is they need to adhere to the architecture practices. Let's say how to communicate, how to pass data from on the event bus, how to raise the event. So if you follow that, you can develop each microservices in different technology. Nobody stops you. So that's the beauty of microservice as well. And it improves productivity of new team members. How? So because the microservice, even if let's say if somebody asks you work on kind of an Amazon website, and imagine if that's a single code base monolithic application, to be able to understand and make a single line of change is kind of it takes a lot of time. Now you divide that into 400 different small applications. Now you want to do some upgrade on the search or some kind of a change in the payment mechanism. That way you only impact that particular microservices. So that helps new team members to be very productive. So these are the few benefits. Okay, so next we'll see the building blocks. So when we talk about microservices, what are the different building blocks, right? It's not just a kind of a set of methods. It's a lot more than that. We'll see that. So these are the basic building block. One is your microservices, which actually runs the logic. Let's say you are kind of making a payment. So accepting a payment is one microservices. Like similarly, searching for a product is another microservice, right? Creating an order is another microservice. So you can have those microservices. The actual logic is inside microservices. But what are the other blocks which are inside which helps this microservice architecture works? Another important block is event bus. So event bus, consider that, let's say once customer decide that he wants to buy this product, okay, customer says add to cart. So now that from order mechanism, then the order service will come into the picture. It adds this particular product to the cart. It kind of keeps on adding. Once customer finalizes that, hey, I want to make payment, it says, okay, from order service, you will raise an event that make payment for this. It goes to the payment service. So that's how microservices kind of connect using event bus. They communicate using event bus. We'll see how more details about it. Also, authentication service is very important part of it, because when so this microservices can be invoked from different kind of clients, from mobile clients, from web client, desktop client. So you need to be authenticated. So how the authentication piece can be done is you can kind of have a single authentication mechanism where you don't have to repeat that authentication at different or each microservice level. You can have authentication service whose purpose is to authenticate the request. That's it. The only purpose is to authenticate request, single purpose. That's done. API gateway. So now let's say I have a website, or let's say I have a project where I've deployed set of APIs. Now, if I have monolithic application, I know that trackgaddy.com/API/something, that's my path. But now if instead of one, I have 100 servers, which have different API endpoints. So now how the kind of a client knows which endpoint should I call? Does client need to be aware about 100 different containers which are running and each container have a different endpoint? No, that's where API gateway helps us. So API gateway takes care of all the mapping from when the request comes from client, where it should be directed. So that's the purpose of API gateway. As a client, API client, we don't have to worry about kind of understanding or being aware about each of the endpoint. And the last basic point is container host. So where do you host the microservices? So that's a container. So we'll move further. Okay, so let's take a look at this deployment diagram, which will give us an idea about the various components. So all this component which we saw over here, they will come into picture over here. Okay, so you see on this side we have web app, mobile app, chatbot. All these are our clients. They make a call. It comes to the API gateway. Okay, API gateway identifies, okay, this call is for microservice A. It calls microservice A. It performs some operation and stores its in own database. So now there's one point to bother or kind of observe over here is microservices A uses Mongo, B uses SQL Server, C uses Cosmos, and D uses MySQL. And each of this service might potentially be developed in different technologies. So then also they work seamlessly inside a microservices architecture. So from API gateway call comes to microservices A, it stores it into a database, it publishes an event on the event bus, and that event, let's say this event is for microservices C, so it consumes the event, processes, stores it, right? So here are the various components which we saw. One is a client, then API gateway, the purpose is to direct the request. Authentication service, the purpose is to authenticate these calls, whatever calls coming before they are kind of directed towards actual microservices. So it goes to authentication service, authentication happens, and then it goes to microservices. And if there's some communication needs to be done with other microservices, an event is published on the event bus and that is consumed. Okay, so I would like to take a pause and ask if anyone has doubt so far or want to kind of ask any question related to the content covered so far.
Yeah, right now there are no questions, Ankesh, so you may continue.
Okay, thank you. All right, so this gives us a high level idea about how the microservices will be deployed and how actually it looks as a high level picture after deployment. Okay, so we talk about API at various ways, various places. So API gateway. So we'll see what is API. So APIs are, when we talk about API, those are RESTful APIs. Generally, RESTful APIs are used in microservices and they communicate over HTTP. They are very simple, they are stateless, they can be cached for better performance and scalability. It supports different data formats, but predominantly we use JSON as it is better supported by various browser clients, mobile clients, other small devices, various embedded systems and all. And all of the major companies, if you see now, uses REST APIs and exposes web API. Maybe Google, Facebook, Twitter, LinkedIn, every company exposes the APIs, RESTful APIs. Why API gateway? As we briefly covered before, API gateway help us in kind of integrating the calls to various microservices. So increases complexity of client integration if client have to keep track of numerous microservice endpoint. So they don't have to. Consider all microservices might be moved to a newer version and might replace the service that client used to call, right? So we just remove one microservice and put another microservice at that place. You don't really have to worry because API gateway takes care of it. Microservices have to handle their own load balancing and failure detection. They don't have to because API gateway can take care of it. Microservices need to handle their own security concern. No, API gateway calls the authentication service and takes care of it, right? So all these things are not required because API gateway does all these things. So the API gateway take a lot of common functionalities out of it and adds a layer in between which kind of seamlessly does all these things. So this is an API gateway routing example. Now from web client, we get a request for create user. It comes over here and it directs towards a create user microservice. From mobile, we get user lookup. Okay, it understand, yeah, okay, this is the domain. It maps to the internal IP, yeah. Perform this function and give me back. Third is user edit, right? So it goes to the user edit service and it does that. So over here from client, it doesn't matter how you call, it comes to API gateway and it internally maps. What's an event bus? An event bus can be classified as a backbone of a decoupled service. So in any application or in any system, communication across components is there. You cannot take away that communication because let's say customer searches a product, then customer adds that product to cart, then customer creates an order, then makes a payment and payment is successful. That is then shipped, right? And it is received by customer. This is how entire flow kind of it's completed. So on each step, once the particular function is completed, that microservices need to inform next microservice that yeah, it is dispatched. Now it is your turn whether it is received, when it is received, yes, no, right? So that's why event bus helps us over here in terms of communication. Allows microservices to communicate with each other without having knowledge to know about each other, right? So it just says that if let's say dispatch microservice, when the kind of a particular product is dispatched, it says that okay, this product is dispatched. Whoever is interested in that status will kind of consume that event and say, okay, now I am awaiting for confirmation of the recipient, right? This is type of pub sub or publish subscribe pattern. Event bus takes a role of middleman and sits between publisher and subscriber, right? As we saw in that diagram. So I'll bring that diagram again over here. So this event bus, this is what we are talking about. So it publishes and consumes. It service A, microservice A doesn't aware whether microservice B, C, D exist. It just says that okay, this is the event. If you're interested, just grab it up. Okay. So that's about event bus at high level. So like this. So a booking, confirm booking request. So a booking service receives the request, it inserts into DB and then says, yeah, booking confirmed. Then over here, so it process payment service receives the request. It says, yeah, process, a payment is done. It see over here, if you see booking event is consumed and payment successful is published. Over here, payment successful is consumed by two different services. One is update seating, that your seats are no longer available, and the booking notification. It sends notification to consumer, yeah, your so and so ticketed book, right? So now single event is processed by more than one microservices. Without this process payment being aware that whom I have to tell, yeah, you do this now. Process service doesn't have to do anything. You just have to publish an event. Okay. Next piece is how to secure microservices. So generally it is done using external authentication provider such as OAuth2. You can use identity server. You can use any other kind of a third party application. There are various which help us provide the authentication providers. Adding an authentication layer in the API gateway. As we saw in the diagram, I'll bring that diagram again. All this call are authenticated first before they move further. So API gateway, first make sure that the calls are authenticated. Okay, and you can also create your own authentication service and kind of register that with API gateway. API gateway will use the custom authentication service instead of any third party. Okay, so that's a simple example. So client first request for JWT is, it's kind of a Java Web Token. So authentication service authenticates that and then generates the JWT and sends it back to client. Now each request client makes, it kind of adds JWT token to the header and it goes to microservices. In between, it kind of is authenticated by API gateway. Okay, so that was about building blocks. Now we'll see how the data management can be done. So CQRS is very popular practice in microservices. That's used. CQRS stands for command query segregation, responsibility segregation. So now whatever operation a user does, we can think of them as a two things. One is user is changing or providing some information or changing some information. Second is user is viewing some information. Generally, these are the two only actions which happens. So one is when we change or alter any information or insert any information, that is a command. And when we want to read the information, that is a query. And if you see, generally the information we change and we want to view is generally different. But most of the time what we used to do, we have a single object which is used for viewing as well as inserting, updating, deleting. But CQRS helps us or kind of allows us to segregate those two different behaviors, because when altering, we are altering a particular object, but when we are requesting, we are majorly kind of interested in set of information which can come from single or more than one entity. So you have to combine 2, 3, 4, 5 entities so that you can show the useful information, right? While ticket, that's kind of a, for example, while you are booking a ticket, you say that I want to go from here to here, this class, and these are the names. Okay, that's your command. But when you actually get the ticket, what you see, okay, from this destination to this destination, this time, this is the seat number, these are the various facilities and all, right? So the command which you provided and the query which you requested are two different things, gives us two different information. So that's a CQRS pattern understands that, and it helps us to do things in a domain driven way. So that's a CQRS. Another is event sourcing. So a lot of these events, so everything is an event. Okay, like I want to create this, that's an create event. I want to update this, I want to view this. All these are the event. So event sourcing helps us to kind of store this event, and in case of failure, we can kind of rerun those event and generate the instances of the data again, right? By just to replaying the events from the event stores. We'll move further. Yeah. So this is how general data request model. So user makes changes on UI. So there's one request. That model is parsed, updates in the database, model is read, and it returns, right? But in CQS pattern, you have two different models. One is user make changes. That's a different kind of information. Okay, it stores the database. But while requesting, you need different. So that's why there are two different models. One is command model and query model. While querying, you can kind of combine more information and give us more information to the user, which makes sense to the user. This is event sourcing. So whatever events come, it processes the event, and then it also write that event into event store. So in case if some failure happens, you can use this event source to replay those events and then kind of figure out then get the latest data state. Similarly, if something goes wrong, and while debugging also you can get this set of events, replay them to figure out what was the issue, right? So that way you can use that for troubleshooting as well. Okay. So this Saga is one of the distributed transaction. So over here, if you want to have transaction across 3 different services, okay, so that's where Saga pattern is useful. So let's take a look at this example. So microservices, there's order microservice, payment, and shipping. Once the order is created, it tells that the order is created by payment microservices, then consumes that event, processes it, and publishes payment process. Then that is consumed by shipping. It consumes and says order shipped, and then it kind of reaches to the customer. But in case something fails, event publisher publishes that event, and it says, it kind of tells back to order microservice that it didn't happen, right? So this pattern is useful when if something is failed, you also notify that, yeah, this is failed using these events. Okay. So we saw a lot of things. We saw building blocks. We saw how data management can be done, requires different models, different patterns needs to be used. So now, what are the success factors for microservices? Logging. So you'll develop microservices, you will deploy them. That's a bare minimum which we need to do, right? But at the same time, as the project gets complex, right, there are more than one, there are hundreds of instances of microservices. A particular set of microservices might be failing, right? And you want to identify which microservice is failing. So if you don't have proper logging mechanism, then you won't be able to determine kind of it, or it will be very difficult or very hard to determine which microservices has failed. So logging is very essential, and we'll see for a microservices project to be successful, apart from that developing microservices and deploying, there are other factors which are very important for its success. One is logging. So you log all the exception, request response, microservice response time, events that are published, right? All logging. So all this information must be logged. Second, monitoring and alerting. So a lot of these microservices are running in a container. So whether the container is down due to some reason, some error, right? So you need to monitor the uptime of microservices, resource consumption by each microservices. Let's say there's some bug and a microservice is consuming a lot of resources. So that also you should be monitoring. Success failure ratio of each microservice. This bug in particular set of microservices, you need to identify, yeah, this are the microservices container which are failing. Don't use them. just throw them away and create new one, right? So that you will be able to do only if you are kind of measuring whether those are getting success or failure. What's the access frequency? The infrastructure dependencies. So you have to monitor all those stuff as well. And there are tools for monitoring, so you don't have to do it manually, obviously. There are tools, various tools for each of this operations or functionality. So we'll take a look at what tools are there as well. Documentation is very important as well, because as the system grows, there are all a lot of isolated or kind of interdependent components, independent components, right? So now how does component communicate? If you don't have that thing documented, then it gets really difficult for someone to understand. So API documentation, so Swagger and all, which can be used to document API. Design documentation, you need to have a deployment view, how things are deployed, right? How each service works, what are the dependencies, network and port allocation and all. So all those documentation is very important part of it, because when you have to understand something, then you have to refer to this. If this is not up to date, then things get lost. Now, next we'll see is deployment and tools. Okay. So microservices are kind of deployed in a container. So there's a slight difference between a virtual machine and a container, right? So if over here you can see the container shares the OS, right? Virtual machine have their own OS, their libraries and runtime and application, but containers are very lightweight. They have their own application and runtime. That's it. They don't own OS. They share the kind of a container engine across. So on a single kind of a VM, you can spin off a lot of different containers. And this containers, actually, it's kind of an image of a microservices. You just deploy this on a container, spin it off, copy that image on another one and spin it off. So that way, same microservice you can run on hundreds of containers. Okay. So now when to create this containers and when to kind of destroy this container on demand, right? Like we talk about that scenario of a sale period or a discount period for Amazon or Flipkart, right? So you need more container during 3 days period, 4 days period, or during days and less during nights. So you need to use this container orchestration, which helps us in kind of a scaling in, scaling out, deployment, provisioning, right? So let's see some of the functionalities of container orchestration. That's a container deployment and provisioning, rescheduling of containers that are failed, scaling and load balancing instances, resource allocation between containers, container redundancy and availability, and health monitoring. So that's the functionality of container orchestration. What are the different frameworks? These are just few frameworks which I have mentioned: .NET Core, Spring Boot, Grails, Helidon. You can use this framework or other framework as well to develop microservices. Container technologies, Docker is the most popular, but they are CoreOS, Linux container, OpenVZ. These are also available. Orchestration engines, there's a Kubernetes, there's a AKS, Azure Kubernetes Service, Amazon ECS, Docker Swarm, OpenShift, CoreOS Fleet. So these are few orchestration engine. There are more as well, but these are the most popular ones. Similarly, API gateways, these are few: Azure Application Gateway, Amazon AWS API Gateway, Ocelot, Kong, TYK. Event bus tools and technologies. So you have Apache Kafka, RabbitMQ, Azure Service Bus, Amazon SQS, Google Cloud pops up. So these are the few technologies, popular technologies for event bus. Logging tools. So when you log, you need to kind of access those logs from a central place as well, right? You cannot really go into each and every microservice and look at the log manually. So these are the few logging tools which logs in such a way that it can be kind of seen or taken out at a single place, kind of a consolidated place. So Fluentd, Graylog, Kibana, Logstash, Banyan, Solo. So these are the tools which helps us in logging as well as looking at those logs. Monitoring tools, Grafana, Prometheus, these two are very kind of a popular. C Advisor, MN, Sensu, Sysdig Monitor, these are few others. Documentation tools, Swagger UI, Apiary, Readme.io, Slate, Gelato, Agilio, and Confluence. So there are various other tools which you can use, whatever is being used in your kind of a organization, but documentation is must. Testing tools, right? Postman, Hoverfly, Packed, Gatling, Rest Assured. These are few tools which can be used for testing APIs and all. Okay. So any question over here? Just a kind of one more break before we kind of come to the last point and conclude.
Yeah, I don't see any questions being asked. So if there are, I will let you know.
Okay, thank you. All right. So all talked and all said about, yeah, microservice should be used. Now I want to use microservice, but I'm not creating a brand new application. I have let's say a TrackGuddy is my application and I want to convert that into microservices. First I need to understand whether TrackGuddy fits into microservices architecture or not. If I think, yeah, it fits, then these are the few steps or major steps which you need to do for converting monolithic application into microservices. So these are set of steps. First is start identifying all the features of existing monolithic application. So whatever application you have, identify all the features and list them out. Now define feature list which can be replaced by microservices. So now pick some of the features which are kind of a common in nature and can be easily independently moved from this application to a microservices. So you first define these are the feature sets. Okay. Now implement non-critical features as a microservices as your proof of concept. So as I said, the components which are not the feature which are not very critical, right? So you start with it, implement those as a microservices and see how it fits together, right? Before you kind of a jump on and do a kind of a big conversion from everything, divide everything and just prepare microservices. Start with RESTful API before implementing event bus. So what does this mean is, let's say you have divided into 3-4 different microservices, right? Now this microservice needs to communicate. So before you bring us event bus, what you can do is you can first step you kind of make one microservice call another microservices, which is not recommended, but you can start with that just to kind of build further on your proof of concept. And once that get more established, you can move that piece into event bus. So implement API gateway, which is must as the services kind of grow, number of services grow, the endpoints grows as well. So keep using single database. So over here, see, this is only specifically if you are converting monolithic. If you are designing new services, you should not go with the single database. Okay. So keep using single database until all features are converted into independent RESTful APIs, and that divide that data model, because the data management needs to be done very kind of properly. So first keep your data source as it is. First move the business logic into different microservices, and then once that is done, you can start moving this data pieces as well. Identify process which needs more than one microservices to complete it. So now, like ordering and shipping, right? So identify such kind of a process and how this will be implemented. Define event and implement event bus for non-critical microservices. So now, initially we are making RESTful APIs. Now we are kind of moving that into a event bus. So now we are moving different kind of API calls between microservices to a event bus, and then we'll kind of do the distributed database transaction and then decompose database into multiple databases. So that's how we can kind of approach about converting monolithic application into microservices. These are the few very good books which help us in kind of understanding more in detail. This was just kind of scratching the surface. Yeah. Yeah, I think I'm done with the content and open for questions if any.
Yeah, so actually I haven't got any questions from the participants, but I must say, Ankesh, this was a really good presentation with definite in-depth coverage. So the last slide was like a bonus slide to us. We were actually, I was not expecting that you would be covering how to convert a monolithic app into microservices. So that I would treat as like a bonus to the entire presentation. So really good suggestions, and the steps suggested over here are really extensive and covers each and every bit of conversion of the monolithic applications to microservices. So
thank you. I'm glad that it was useful.
Yeah. So as I don't see any questions over here, I would like you to summarize if you have to something, and then I would put the end note to the presentation, and we can close the session as well as the event.
Okay. Yeah. So I would just kind of like to add one point. See, microservices is very good architecture only if it fits the bill, right? If it is required, you need to understand first that where the microservices architecture is required to be implemented. But let's say if it's a small application, then implementing microservices can be overkill. So you have to make that judgment call when to go for microservices and when to not. So not everything needs to be divided into microservices because it comes with its own set of complexities, right? So if the application is simple, the complexity will outweigh the advantages which you get. So that's a careful judgment call which we need to take for using microservices. Yeah, that's it. Thank you for the opportunity.
Yeah, thank you for such a good presentation and the efforts you have put. I know that you were traveling for the last 2 days and were on the road, but it was really nice of you to agree to make a presentation after such a gruesome journey of 2 days. So thank you once again for all the efforts. And I would also like to thank all the participants and all the supporters of this particular event, this being the last talk of the event. In SURATi TechTalks, we had over the last couple of days a total of 16 talks on various topics, and all the speakers have done a really excellent job. And I would like them to be again the speakers again and again on our next Tech Talks as well. So once again, with that, I would like to thank Surat Municipal Corporation, Surat Smart City Development Limited, Computer Society of India, Surat chapter, as well as Surat User Group for supporting us in this event. I would also like to thank my staff over here at AIC SURATi iLab for continuously working on this particular event since last couple of weeks. And last but not the least, I would like to thank from the heart my good friend Hemangiri Goswami for being instrumental in making this event such a success. So once again, thank you all and have a nice day. Bye for now from AIC SURATi iLab. This is Tejas Patel, the CEO, signing off. Jai Hind.